Greetings to you all. Dumelani sanibonani abushini molweni. Today we are going to be doing financial mathematics, and then we are going to take it back to grade 10 and grade 11. Okay, so we were taught about investments in grade 10 and 11. And then we know that once we invest money, we can get an interest in a form of a simple interest or in a form of a compound interest. So the formula for the simple interest is A equals to P into 1 plus IN, and then for that of the compound interest, it's A equals to P 1 into 1 plus I close bracket to the exponent n. So where P is the present value of the investment or a loan, is the present value, okay, original amount at the beginning, okay, where A is the accumulated amount for future, is the accumulated amount of future value of the investment or loan after a certain period, which is n periods. N is the time period, or it can be in years or in months depending on the type of interest. R is what? R is the interest rate as what? As a percentage, where I is the interest rate as what? As a decimal. So here we'll have to, if it's 12% or 10%, for us to get I, we'll just say 12 divided by 100, so that we can get what? We can get I as a form of what? In a form of a decimal there. So without any waste of time, let us just go straight to the examples. Example 1. What do we have on example 1? Mpo invests 5,000 for 6 years. Find the future value of his investment if the interest she receives is, okay. Now A, 12% per annum simple interest. So in this case, we know the present value. The present value is how much? The present value is 5,000. Value is 5,000. Okay, it's 5,000. We also know what? We also know what to call the time period. N is 6 years. Is what? 6 years. 6 years. And now for A, they say is 12% per annum simple interest. So we need to get I. Our I is going to what? Is going to be 12 divided by 100. 12 divided by 100 is going to give us 0.12. 0.112. Okay. So now we want to get what? This is for A. Okay, for A. Now what are we going to have? We want the future, find the future value of his investment. So this is going to be the accumulated amount is equal to the present value 1 plus IN. Okay, this is going to be 5,000 into 1 plus I is 0.12. The time period is 6 years. So after 6 years, Mpo is going to have 5,000. 1 plus 0.2 times 6. Mpo is going to it's 5,000. Mpo is going to have 8,600 rands. This is going to be the accumulated amount from Mpo after how many years? After 6 years. So also for B we are told that okay, now it's 12% per annum compound interest. Okay, so for compound interest we know that A is equal to P into 1 plus I to the exponent n, where p, which is the present value, which is how much, which is 5,000, 1 plus, now what is the interest in decimals, 0,12, n, which is the time period, is 6 years. So the answer is going to be 5,000 into 1 plus 0,12 to the exponent 6. So now Mpo, if his investment is what? It's compound, it's a compound interest. Now Mpo is going to get 9,869 rands, okay, which is a bit more, than the accumulated amount when it is invested in simple interest. So the better option will be that for the compound interest. Okay, now this was just a small revision of what we were taught in grade 10. Now we also have different compounding periods. Okay, up to now we have dealt with annual interest. Okay, those interests were annually from the previous example. However, it can happen that interest can be quoted per annum, okay, per annum, but it is calculated over different time periods during a year. Okay, it can be quoted per annum, but it is calculated over different time periods during a year. Interest can be calculated annually, like the one we did on the previous example, or semi-annually, which is half yearly, twice per year. In a year, interest is calculated twice, every 6 months. Quarterly, interest is calculated 4 times per year, every 3 months. Okay, monthly, it is calculated 12 times per year for every month. Okay, daily it is calculated 365 times per year. So but we are including what? We are not including, we are excluding leap years. We are excluding leap years. Okay, so let us do the examples where we'll be having what to call an interest that is quoted per annum, but what to call it is calculated over different time periods. Okay, let us do example 2. Now example 2, calculate the value of an investment of 15,000 after 3 years at an interest rate of 15% per annum, compounded annually. Okay, so for this one, we know that interest is only calculated once a year. Okay, so how are we going to do with this one? We're gonna say A. For A, we know that this is what? This is P. This is the present value, and this is what to call our interest. Okay, so let me just write it there. P is equal to it's 15,000, and what to call our I is going to be equal to 15 divided by 100, which is equal to 0, which is going to be 0,15. So now let us do A. For A, we're going to have A is equal to P into 1 plus I to the exponent n. So this is going to be 15,000 1 plus 0,15 into, because it is annually. Okay, now for what? For how many years? For 3 years. Okay, 3 years. So this is going to be n. Okay, n is going to be 3. 3, which is equal to 15,000 1 plus 0.15 exponent 3. So we're gonna get this is going to be the accumulated amount is going to be 22,813, okay, comma 125. If it is compounded, how? If it is compounded what to call annually. Now let us come to check B. Okay, B. How are we going to deal with B? With B, we're still going to have A is equal to P1 plus this is going to be I because it's half yearly, I over 2 and then this will become N times 2. Okay, now why is this half yearly? Because it is going to be what to call interest is calculated twice per year, okay, in every 6 months. So how many we're going to have in 3 years? We are going to have what to call, we are going to have two halves, meaning we are going to have 6 we are going to have 6 periods of interest, because in a year we are going to have 2 periods. For every 6 months we put interest, another 6 months we put interest, so we are going to have 6 periods in 3 years. So this is going to be equal to 15,000 1 plus we have what 0.15 over 2 3 times 2, so that will be 6. So we have how many? We've got 6 periods. That will be 15,000 1 plus 0.15 divided by 2 3 times 2. So this is going to give us 23,149,552 rands. Okay, so we're gonna get that much. That is for what? That is for half yearly, when it's compounded half yearly. Okay, now let us come and do C. For C, we're going to have A is equal to P into 1 plus I. Now how many quarterly? They said quarterly, meaning interest is going to be calculated 4 times per year. So this is going to be divided by 4, okay, because that interest is per year, it's per annum, but it's going to be divided into 4 parts, because for every 3 months we need to put what to call interest, and this is going to be n times 4. Okay, so we're going to have 15,000 1 plus 0.15 over 4 into 3 times 4. Okay, so we are going to have 12 periods in 3 years. So that will be 15,000 1 plus 0.15 into 3 times 4. So this is going to be no, this is supposed to be 15,000. When I get 23,331,881. So this is going to be the accumulated amount if the same interest of 15% per annum is compounded quarterly. Okay, So let us come to do what? To do monthly D. Okay, so what happens if our interest is per annum but is compounded monthly? So we still do the same. A is equal to, going to equal to P into 1 plus I. How many months do we have in a year? We have 12 months. So this interest is said to be divided for each month, and then this is going to be n times 12. So how many months do we have in 3 years? This is what I'm trying to get there. So this is going to be 15,000 into 1 plus 0,15 divide by 12 into 3 times 12. So we're going to get the number of months in 3 years. That will be that has to be 15,000 into 1 plus 0,15 divided by 12 into exponent 3 times 12, and we have how much? So we're going to get 23,459,16. Okay, so we can see that as we compound this for different time periods during a year, the accumulated amount continues to increase. Here it was compounded half yearly, quarterly, and here is monthly. So if interest is added for every month, so it's gonna give us what at the end of the period of which we are investing the money, we're going to get a greater amount. So let us come here to wrap up our lesson by doing the last one. For E, what are we going to have? For E, when it is compounded at an interest of 15% per annum, compounded daily, that will be A is equal to P into 1 plus I over 365, and then we got N and the number of years times 365. So I'm trying to get the number of days there because this interest is divided by the days. So I'm trying to get the number of days in a year. Okay, in 3 years. Okay, that will be 15,001 plus 0,15 over 365, and then this is 3 years, 365. So from here I'm going to get the number of days in 3 years. This is the interest per annum, but it's divided into days. Okay, so this is going to be equal to 15,000 into 1 plus 0,15 divided by 365 days, and then how many days are in 3 years. So now I'm going to get 23,522,51. So this is how we do the different compounding periods. I hope you understood. Good people, please try to do the exercise that I'm going to give to you, and then we'll meet on the next lesson.